Hello, everyone. Welcome to the AIAA UNSW Speaker Series podcast. I'm your host, Regina, and I'm a fourth year aerospace engineering and material science student at UNSW. Bit of housekeeping rules for the viewers. Please keep your microphones and video off for recording purposes. However, there will be an opportunity to ask questions towards the end, or you can put them into the Zoom chat. So first off, I would like to acknowledge the traditional custodians of the various lands on which we work today, and the Aboriginal and Torres Strait Islander people participating in this meeting. I pay my respects to elders past, present, and emerging, and recognise and celebrate the diversity of Aboriginal peoples and their ongoing cultures and connections to the lands and waters of New South Wales. So for today's speaker series, we have a very special guest who will be talking about his work industry, perspectives, and insights into space law and strategies that have enabled the world to grow closer and connected more than ever before. Working as a legal officer in the Royal Australian Air Force, Duncan Blake, welcome to the AIAA UNSW Speaker Series. Would you like to please introduce yourself and let our viewers know what you do?
Thank you very much. So I'm currently at UNSW Canberra as a lecturer there, but I'm also a reserve legal officer with the Royal Australian Air Force. I do some time with the Royal Australian Air Force, particularly what was the Defence Space Coordinating Office, what is going to become the Defence Space Division. And I also with a unit called Military Strategic Commitments, which is about advising government on commitments that the military should or shouldn't make. And my element of it is the legal component of that, the legal framework that would apply. I also do a little bit of space law commercially, and I'm doing a PhD in space law at the moment. And I also founded and helping to manage something called the Woomera Manual Project, which I think we'll talk about later.
Thank you. It is very nice to meet you. So
Likewise.
Let's start off with your very recent TEDx talk. So This was a very interesting listen. And I was just wondering, you mentioned about how it's up to humanity and not the governments or corporations on how space should be used. How do we as a general public contribute to the space industry?
Yeah, well, absolutely. So you see in the news that billionaires like Jeff Bezos, the founder of Amazon and Blue Origin, and Richard Branson from Virgin Galactic and Virgin Everything Airlines, Mobile, etc. Elon Musk, the founder of PayPal, Tesla, SpaceX, have been to space or are sending rockets to space, frequently. Elon Musk, for example, sent a Tesla vehicle into space. But it's not just for them, and it's not just for boomers or Gen X like me, Gen Y, or whichever generation you happen to be. And it's not just for the tech-savvy people either that have their own startup companies. It's for all sorts of people. And it's not just for government and militaries. And that's I acknowledge that the United States Space Force has been recently established. The UK has done that. Australia is doing so. France, Russia, China, Japan, they've all done so. But the drafters of the Outer Space Treaty, for example, which is a primary document that space lawyers focus upon, in the 1960s wanted to enshrine the idea from the very beginning that it's not just for all of those people. It refers to the use and exploration of outer space as the province of humanity. So not states, not corporations, not military forces, but the province of humanity for all of us. We do need to understand how to live on this planet. It's not like we own it, not live on it like we own it, but live on it like it's the only place we have to live in the universe, because frankly, it may be the only place we have to live in the universe. And that means planetary science, understanding how planets work and whether there are other options out there, Earth observation, so satellites that are looking down on Earth and observing Earth, to understand how human activities is affecting our planet and how to do things more sustainably, and communication across the globe, because we have planet-size challenges confronting us at the moment. And planet-size challenges require planet-size collaboration, which means we all need to talk, right? We're not going to tackle the challenges if we're tackling each other. So in the TEDx talk, I said to everyone, look up at the stars. There's lots of good things happening up there, but there's lots of scary things too. Typically, there's 3 C's that are used to describe challenges happening in the space domain right now. It's more competitive, it's more congested, and it's more contested. And I might go over those later, but it's sad to think that in the future, when we look up at the stars and what we might see when we look up at the stars in this generation, the next generation, generations to come is going to be different. There's going to be a whole lot of satellites going every which way. We won't be able to see the stars perhaps, and there'll be lots of competition, lots of military, potentially conflict going up there. So the question, what can you do about it? Well, being part of AIAA is a good thing. And I note that, most of the people in AIAA might have an engineering or a science or a relatively technical background, but you shouldn't think I didn't study law or politics or international relations and therefore I can't have a say. Your opinion, and I should say your informed opinion, your informed opinion is just as valid as anybody else's. There's also the Space Generation Advisory Council, so I recommend everyone checks that out. That's meant to represent next and future generations. And the United Nations Association of Australia, you can get involved via them. The Space Law Council of Australia in New Zealand. The Australian Space Agency is quite active on social media, so you can follow them by social media. And they do public consultations pretty regularly, so you can get involved in those. But space is absolutely for everyone. It matters to all of us, and what's happening up there is going to affect all of us in the future and generations to come. So absolutely everybody needs to be involved.
Yeah, definitely. So just coming off the back of that, how far has Australia's space industry come over the years?
Yeah, so we started in Woomera in South Australia in 1947. There was something called the Long Range Weapons Establishment. So Woomera is actually an Aboriginal word referring to the thing that is used to extend the range of a spear. So, very, very, relevant for a long-range weapons establishment. And Australia collaborated with the US, the UK, and an organisation called the European Launcher Development Organisation at that time. Throughout that period, from 1947 to 1971, we launched in November 1967, we launched RESAT, so Weapons Research Establishment Satellite, on a US rocket. So we were the 7th nation to have a satellite. We were the 3rd nation to launch from our own territory, but it wasn't our own rocket, so we don't quite qualify as a spacefaring nation yet. And then between 1971 and perhaps 2017, there was a relative hiatus, with the exception of AusSat, which became Optus satellites, and an attempt to establish launch sites on Christmas Island and far north Queensland. So those happened. But now, since 2017, we are well and truly on track to triple the size of the industry in terms of output, in terms of GDP, in terms of employment. And they desperately need a wide range of skills. And so the estimate's been given that by the next decade, as much as 50% of jobs will have a space component to them. So it's not just engineers, but also, for example, lawyers, metalworkers, doctors, other health workers, accountants, ethicists, educators and trainers will all have a space component to them. And there are companies involved in satellites, in manufacturing satellites. So UNSW Canberra Space has manufactured satellites together with Air Force Headquarters and Defence Science and Technology Group. Fleet Space down in Adelaide has aspirations for a constellation of over 100 satellites, I think it is. Innovore in Adelaide is building satellites. Skycraft in Canberra is building satellites and has aspirations for a large constellation, over 100 again, I think. UNSW Sydney, the Australian Centre for Space Engineering Research, has launched satellites. There's the Seven Sisters collaboration, which is developing something for lunar orbits as well. Then there's launch vehicles, Gilmore Space Technologies, Black Sky Aerospace, Thunderstruck Aerospace, and there's some entrepreneurs in Melbourne who are developing launch vehicles. Launch facilities, Southern Launch down in South Australia, Equatorial Launch Australia up in Nhulunbuy, and there's one at Abbott Point in Queensland that Gilmore Space Technologies are going to use. In terms of space domain awareness, there's a company called Electro-Optical Systems that are pointing lasers up into outer space to get a very precise track on where things are. There's a company called Silentium Defence who are tracking passive electromagnetic radiation, essentially. So when from television signals or radio signals bouncing off things, they can track those and tell where things are. Western Sydney University is developing means of space domain awareness. A company called Leo Labs just recently announced they're going to develop a space fence, something called a space fence in Western Australia. There are big projects like the Artemis program that is the next NASA's aspiration to send the first woman and the next man to the moon, and Australia's developing a lunar rover to be part of that. And in fact, there's a Sydney-based company, I can't remember the name of the company, who are collaborating with a Japanese company for a robotic arm on a lunar rover in a purely commercial mission, not a government mission. There are people thinking about space resources like the Australian Remote Operations for Space and Earth. The acronym is AROSE. So they're leveraging off the experience that Australia has in respect of remote mining and thinking about how to do that in the future. There's a startup called Near Earth Object Resource Atlas, who are mapping where near Earth objects are that might be available for space resource exploitation. And there's a whole lot of downstream services, people thinking about, well, how do we use all of this data that we get from outer space? And just one example of that is the digital cube, something called the digital cube. Just trying to remember the details of it, but it's not coming to mind. But there's lots of downstream services that are being developed as well.
Yeah, definitely. So Australia's space industry is definitely still growing and it's only beginning to pick up its momentum. And so regarding this, how do you think space will actually contribute to our economy? Like, what's the impact?
More jobs, greater skills and expertise, more infrastructure. Ultimately, we want to earn export dollars, so sell to people overseas, provide services to overseas, so launch satellites for overseas customers. A big part of what space does is about facilitating other parts of the industry through communication satellites, position, navigation and timing. So position, navigation and timing is like GPS or the global positioning system. It's what enables us to know with high precision exactly where you are using GPS. GPS is the US specific version of position, navigation and timing, but there's a Chinese version called Beidou. There is a European version as well. There's a Russian version called GLONASS. There's some regional versions of those as well. So, and then there's Earth observation. Earth observation is satellites looking down on Earth for a whole variety of reasons. In a military context, that's known as space-based intelligence, surveillance, reconnaissance. So EO/ISR, if you like, and all of those things, the comms, the PNT, the EO/ISR, facilitate things like natural resource management, like logistics, leisure and recreation, defence, telemedicine, traffic management, public services, all the way down to Netflix and TikTok, and making those sorts of things work. And then there's resources as well that might be used in or extracted in space and used in space, and on the rare occasion maybe brought back down to Earth as well.
Yeah, so you were just talking about the resources, like what in particular can we obtain, like in terms of resources? Like, why are people so interested about space? What does it have to offer?
So there in terms of things that might be usable back down here on Earth, there are rare earth minerals. There is a global shortage of sand. I don't have the figures to hand, but China over the last 5 or 10 years, I think, has mined more sand than has ever been mined before that period. And that sand is used in concrete, and that sand is used in computer chips, for example, and all sorts of electronics. And people have probably seen in the media how there is a global shortage of computer chips. So alternatives to that and a variety of other rare earth minerals for other purposes might be brought back down to Earth. But that's actually the sort of rare exception. In most circumstances, resources extracted in outer space are going to be used in outer space. And so the thing that is going to be most valuable in a sense is water. And NASA has indicated that they're prepared to buy water, and they've said if you're a company that believes you might be able to extract water, then let us know, and we can offer you a contract. And there's a big company, I can't remember exactly which big company, but has put a price on water, and it's in the realm of thousands of dollars per litre. Again, I don't have the figures exactly to hand, but the water is essential to life if we're going to have human presence off Earth. It's essential to life in its own right, but it's also essential because it can produce oxygen and also hydrogen as well. And hydrogen can be used for rocket fuel. So you can have a refueling station essentially on somewhere like the moon. There's also helium-3, which I understand can be used to generate an enormous amount of energy. But I don't know the science behind that. Some other people who are listening may understand the science behind that. And then there's regolith, the essentially the sand that or the dirt that you might dig up on somewhere like the moon, that you could make concrete or building material out of. So there's that. There's also space-based solar power generation. A lot of people think that's unlikely, but essentially, if you put big solar receivers in outer space and then send energy back down to Earth, that could be a game changer. But having said that, I recommend to everyone another podcast. There's a lady, Dr. Natasha Hurley-Walker, in a podcast on ABC Occam's Razor, talked about the fallacy of endless economic growth. And if you think about 2% economic growth going on forever, if economic growth is linearly connected with energy growth, the energy consumption, then she demonstrated, she's an astrophysicist, she demonstrated that within several hundred years, we would use up all of the energy in the solar system. Within a couple of millennia, we would basically not be able to sustain our economic growth with all of the energy in the universe. So if energy and economic growth are linked, then it's just not sustainable, which is why green growth economics is really about trying to de-link growth from greater consumption. Although a lot of people are cynical about that, they think they can't be de-linked. So there's a degrowth and a post-growth economic models that people are developing as well. So, you know, the resources in outer space are important, but I think we need to think about how to do things more sustainably and not just think of, you know, space out there as somewhere where we can just get more of whatever and fix all of our overconsumption on Earth.
Yeah, definitely. We can totally see like the potential of what space can offer. So just veering towards the policies, the Outer Space Treaty states that the outer space shall be free for exploration and is not subject to national appropriation by claim of sovereignty. Will there be any issues when certain countries want resources? Like, will there be any conflict? How does the space law make sure there's no conflict?
Well, that's challenging. I mean, it's true that you can't own any part of outer space. The challenge, though, is that certainty of ownership over something. If you're an entrepreneur and you're developing, you know, infrastructure, equipment, whatever, to go out into outer space and to extract resources, then you want some certainty of ownership in order to justify the investment that you're making into developing your infrastructure and your equipment. So certainty of ownership is apparently essential for commercial exploitation. And people would say that it's essential for the avoidance of conflict as well. If everybody is certain about who owns what, then you can avoid conflict. I think that argument's a little fallacious, though. And I think that we need to distinguish between, on the one hand, control over resources versus ownership of resources. So a mining company, for example, tends to get a mining lease. It gets a right from the government to use an area of land, and it has all sorts of regulation about how it uses that land and its obligation to return the land to its natural state as far as possible after they finished mining, right? So that's sort of more in line with the concept of stewardship. And I think the First Nations people of Australia and around the world, for example, are quite familiar with this idea of stewardship, that you don't own the land. You are simply a steward of it. You have control of it, and you have an obligation to others, to your whole community and to next and future generations in respect of the resources that you do control. And I think that an unrestrained rush to own all the resources will almost certainly lead to conflict. Space is increasingly competitive, congested, contested, and each of those has the potential for conflict. So, you know, competition, congestion, with conjunctions between space objects causing more space debris, that could certainly lead to conflict. And the military contesting outer space could certainly lead to conflict. And what we need is not just laws, but we need norms. And what I mean by norms is something broader than laws. We need to know, we need standards, we need to know what are the expectations that one space user has of another space user. Those expectations in any part of society is what helps society to function effectively. And if we have a good idea of what those norms are and what normal looks like, then we know, okay, that's exactly what I expected to happen. That's fine. It's not something that I need to feel threatened about, that needs to generate conflict. So I've previously written on this, and the ideal would be that, because there is no police force in the international community, right? So states have to police themselves, essentially. So the ideal would be if any state in the international community could say, in respect of an activity in outer space that was suspicious, first of all, we know you did it. Attribution, we've got attribution. So that implies we've got sensors that are looking up there and understanding what's happening. We can demonstrate to the satisfaction of the international community that you did it. So it's verifiable. Not only do we know you did it, but we're willing to share all of our data with others, which has its own challenges. There's a normative framework that covers irresponsible behaviour. The normative framework is widely accepted throughout the world, so there's legitimacy. It clearly applies in this circumstance. So there's clarity. We have the capability to do something about it, so there's capability. The consequences will be substantial, so they'll be effective, and imposing those consequences won't have unacceptable adverse effects on us. And if the states in the international community could say all of that, then it would be relatively stable. The truth is that we don't ever have 100% of all of those things, and we never will have 100% of all of those things. But the closer we get, the more stable we are. So we need attribution, verifiability, a normative framework, legitimacy, clarity, capability, effectiveness, and what I call minimum recoil. So that, yes, there is a possibility of conflict. Yes, we have norms that are being developed, but we know what we need to do. It's just how we develop the norms and get clarity and put states in a position to police each other.
Yeah, thank you for that. So you mentioned the key issue of space debris. What are some solutions to maintaining space debris? So in your TEDx talk, you actually mentioned that there were like 10,500 satellites launched, and about 3,200 of those are still in orbit. What really happens to the other satellites, and how can this be managed?
Yeah, so in addition to old satellites, the old satellites account for something like 7,000 or 8,000 pieces up there. A lot of those will have deorbited already, and hitting the Earth's atmosphere is pretty effective at burning up an old satellite. But there's still quite a few old satellites up there. For example, in what's called the graveyard orbit beyond geosynchronous Earth orbit. In addition to those, there are discarded rocket bodies. There are bits of satellites that have crashed into each other. So in 2007, the Chinese tested an anti-satellite missile by blowing up one of their own satellites. It split into lots of bits of debris, and those are circling the Earth at the moment. The trackable debris out in low Earth orbits, so relatively close to Earth, is somewhere between 22,000 and 30,000. It changes all the time, and it depends on exactly how you record these things. But that's only the trackable debris. So the trackable debris out that far needs to be 10 centimetres or bigger in order that it can be tracked. Out even further, geosynchronous Earth orbit, it needs to be around 1 metre or bigger in order that it can be tracked. And yet a paint fleck, of a couple of millimetres in size can do substantial damage to a satellite. If it's a centimetre in size, it could actually destroy a satellite. So in terms of the debris that is not tracked, there's statistical modelling about what is believed to be the population of pieces of debris out there that are not tracked and not big enough to be tracked, and it's somewhere between, I think, 500,000 and 1 million pieces of the smaller pieces of debris. So that's really challenging. And the question is what sort of things can you do about it? Actually, I should just mention the Kessler Effect. So the Kessler Effect is a reference to the fact that if you have one, say, piece of debris colliding with a satellite, that satellite then becomes more pieces of debris, which can then collide with more satellites and create even more pieces of debris. So you have a cascading effect. And that's known as the Kessler Effect. And if there is a certain density of satellites and debris in a certain orbit, then you're said to be close to the Kessler Effect. And there's debate about that. But certainly that's not where we want to be, because when things are in orbit and they continue in orbit for a very long time, it can take, depending on your orbit, anywhere between years to millennia for them to deorbit, for the space debris or the satellite to deorbit. So there's space debris mitigation. Space debris mitigation is essentially rules about not creating more debris in the way you design your mission. So, don't leave rocket bodies up there. Design your mission such that the rocket bodies deorbit back to Earth. That's space debris mitigation. And then there's active debris management, including active debris removal. So the first thing you might do is to extend the life of satellites. And you can, I should just say on the space debris mitigation, so the rules about that, the Committee on the Peaceful Uses of Outer Space, or COPUOS, has published something called Space Debris Mitigation Guidelines, and also guidelines on the long-term sustainability of space. They get implemented through national regulation, and even below national regulation, there are then very technical specifications. For example, NASA has the Orbital Debris Assessment Report. So you follow a methodology and you get a very good idea of the probability of collisions between two objects and the probability that your spacecraft will survive, or some part of it will survive deorbit and cause a problem down on Earth. But in terms of active debris management, there is on-orbit and life extension. So there's various means of doing that, of salvaging a satellite. So you could grapple it with a robotic arm, you could use magnets, you could use a spear. There's been a mission to explore spearing one satellite, using a net, an electronic tether. But as you listen to those, it probably occurs to you that, wow, those things could actually be misused, right? So there's a dual use problem. And then there's the possibility of deorbiting. And so you might insist that a satellite keeps a certain proportion of its fuel spare until the end of its life, for end of life disposal. So at the end of its life, it has to deorbit itself to make sure that happens quickly. But then there are external means of delta V, or change in orbital dynamics, essentially. So you can introduce energy by laser. So pointing a laser at a piece of space debris, and ablation of the surface of the piece of space debris causes it to experience delta V, or photon pressure. Incredibly, the mass of the photons is sufficient to, over a long period of time, to create delta V. Artificial atmosphere, but again, the sorts of things that you might use to deorbit a piece of space debris are also things that could be misused as well. So again, you have this dual use problem about how do you make sure it's not going to be misused. So there are solutions. There's not like a 100% good solution. There are many solutions being developed, and hopefully they can be developed quickly. But one of the biggest challenges is the economic problem. Who's going to pay for it? Because, if you're a company, you've put satellites up there, how much interest do you have in paying for some part of space to be cleaned up? Why should it be your problem to clean it up? And the same argument could be put by lots of different states, as in, Australia could say, well, we have very few satellites. Why is it our problem to clean up any part of space? So the economics is a challenging issue as well.
Yeah, definitely. So as satellites are continuously being launched, which is really awesome, but there's also this other implication, like rather than trying to get rid of satellites. For example, the satellites can actually obstruct other research, for example, observational astronomer research. So it actually prevents them from exploring outer space. How important is this issue?
Yeah, well, so as I said before, the things that we get out of going to outer space, and I'm sort of conscious of the fact that climate change is a big issue currently, as it should be, and I know that Prince William was critical, for example, about Elon Musk and Richard Branson. He didn't mention them specifically, but he essentially implied that rather than billionaires spending lots of money on going to outer space, we need to focus on what's sustainable here, right? So space is important for planetary science to understand how planets work. It's important for Earth observation to understand how our human activity affects things down on Earth. It's important for communications as well. And we need to do all of those things. We need to be able to communicate. We need to be able to see up there. And frankly, we also need to be able to look up and imagine. And it's hard to overestimate the simple value of being able to look up at the stars and see what's going on. But for the astronomers in particular, when you have constellations, so the SpaceX constellation, which potentially could be a huge benefit, we're talking about at least 12,000 satellites. They've filed for even more than that, potentially around 42,000 satellites that would provide global broadband. So imagine you've got your smartphone, and normally when you travel overseas, you might have to change your service provider, but you don't. You don't have to change your service provider. You can have one service provider the world over, and it could be SpaceX. SpaceX would love that, obviously. And a lot of remote areas that at the moment have pretty patchy access to communications of various sorts would have access to SpaceX. But you put 42,000 satellites in orbit, and it means that when we look up at the stars 10 years from now, when you see what you think is a shooting star, it's not going to be a shooting star. It's going to be a satellite zipping past. And SpaceX is just one of quite a number of companies who are planning big constellations. And I've mentioned, for example, how Fleet Space wants to have a constellation of, at least 100 satellites, and Skycraft as well. There are other constellations in the thousands that are being planned, all over the world. And just recently, and this one's particularly interesting, Rwanda filed for or sought approval for access to frequency, because if you're doing a space mission involving a constellation of satellites, the first thing you want to do is secure access to frequency. So they sent an application to the International Telecommunications Union, for a constellation involving, I think it was just over 327,000 satellites. And the company that worked with the Rwandan government to put in the application is called Marvel Space Communications Company, which probably is kind of a reference to the mythical land of Wakanda from the Marvel universe. But it's difficult to, it's a serious application. It's a formal government application, but there just isn't enough capacity globally to launch 327,000 satellites in the next 14 years, which is essentially when they'd have to launch them by. So the number of satellites being launched is a problem. It's a problem in terms of being able to look up. It's a problem with access to outer space as well. And so, for example, there's a launch provider in New Zealand, Rocket Lab, and the CEO of Rocket Lab, a guy called Peter Beck, has said it's getting to the stage where it's difficult to pick a clear path for a launch through all the satellites up there. And he and other leaders of launch providers are seriously concerned about being able to launch without fear of colliding with anything in the future.
Yeah, definitely. That is an issue that we need to consider for the further exploration of satellites. So moving on to your project. So I've heard you are the founder of the Romero Manual Project, and you have been working on this for the last 10 years. Could you let the viewers know what this project is about and why you decided to launch this project?
Yeah, so when I studied space law at McGill University in Montreal in 2010, 2011, and my thesis was about the need for this Woomera Manual project. It wasn't that innovative because there have been similar manuals in respect of similar domains. So the San Remo manual applicable to international law applicable to armed conflict at sea, the Tallinn manual on international law applicable to air and missile warfare, the Harvard manual on international law applicable to air and missile warfare, the Tallinn manual on international law applicable to cyber warfare. So in other domains there have been similar manuals, and so the idea of a manual for space was not that innovative. And when I say, I'm the founder, well, that's true. It sort of came out of my thesis, but there's a group of 30 people who have been involved in this project, or more than 30 people, involved in this project for several years. And the idea is that we need clarity. We talked before about the possibility of conflict in the space domain and what we do about the possibility of conflict in the space domain. And we need clarity about norms. So it's not the case, and sometimes you will hear people say space is a new Wild West. That can be frustrating to hear. There's all sorts of things that are wrong about that terminology. But it is true to say that the space-specific laws, like the Outer Space Treaty, are relatively sparse. And when you look at them, you think, well, there seems to be lots of gaps and uncertainty about the law that applies. But the fact is there's much more law that applies to outer space. It just might not specifically say space in the article, for example. So Geneva Conventions to do with law of armed conflict, they apply to space as well. And that is a large focus of the Woomera Manual. It's about international law applicable to military space activities. And the idea is to provide clarity. So the project is not creating law in any sense. Really, it's only states that can create law. States create law by agreeing to new treaties, or they create law through their own practice and by committing to that practice as something which they regard as legally binding. So, we can't make law. What we can do is clarify existing law. And these experts come together from all around the world, and we meet regularly, and we seek to articulate very succinct rules. So, a couple of lines at most, and then several pages of commentary essentially on what that rule is. So an example might be along the lines of there's a general rule in law of armed conflict that any object by its nature, location, purpose or use, there's more to it, but it could effectively be a legitimate military target. And there's several tests as to whether something meets the criteria for being a military target, a legitimate military target. Well, that applies to space as well. And if you don't meet the test, then you can't be a legitimate military target. And so we have a rule about that, about determining whether a satellite could constitute a legitimate military target and in what circumstances. And these experts come together, and we draft these rules. And the really valuable thing about it, there's a couple of valuable things about it. One is, really it's about convenience. It's not that the experts are a source of law in themselves, because we can't create law. We're not law. We're not creating law, but we can be very convenient and perhaps authoritative in the sense that if you were trying to find all the bits of law that might apply to a given scenario, you could go off to this source and this reference and that reference, and maybe this journal article and this textbook, etc. We could find it all in one consolidated book, essentially. And that's what we aim to do, to be convenient. And it has worked. It's worked in the San Remo manual to do with naval warfare. It's worked in respect of the Harvard Manual on Air and Missile Warfare. It's worked in respect of the Tallinn Manual, in respect of cyber warfare. So when government officials, military practitioners, so I, for example, have used the Harvard Manual quite a lot in my military career. When we're looking for the law that applies in a given scenario, a source like this is invaluable. So it becomes very authoritative in that sense. So it's a long process. We started essentially in late 2016. We would have liked to have been finished by now. We had planned to have a state engagement process last year. And I should just explain that quickly. So when the experts come together, they don't represent each other. They don't represent anyone. And that's important, because if they came there and they were representing a state, then it would be like any international negotiations. It would become quite political, which is not necessarily a bad thing. There are, the politics, the policy issues to be worked out are important. But we're not seeking to work out political issues between states. We're seeking to state the law as it is. And so it's important that these experts are there in an independent capacity. But having said that, we do need to go and engage with states officially and say, so this is what we've drafted. Ultimately, it's states who make law. We need to know what you think before we publish this, because that might, they might say, well, actually, you should go looking here because we've actually undertaken this practice regularly. You may not have been able to find it, but now we're telling you, and you should include that in there, and that'll influence what people believe the law is. So we're going to have a state engagement process, probably around May, somewhere like that, next year. And then I think publish around 2023, early 2023.
Awesome contribution. Actually, we have some questions from the students. So What is the most immediate pressing issue that faces space law, and how do you think this can be solved?
Well, it's hard to say what the most pressing issue is. I previously talked about three challenges, space becoming more competitive, congested and contested, and each of those are true. In addition to those three challenges, there are issues like human settlement off Earth as well. But I think probably the biggest issue is what you might call space traffic management. So just as we need traffic management for air, for ships, for vehicles, we need traffic management for space as well. When you're hurtling down the road at 100 kilometres per hour and you see another car coming towards you at 100 kilometres per hour, you're confident that it's not going to hit you because there is a law that says stay left in Australia or stay right, depending on what country you're in. But there's no rules like that in space. Who has to dodge who when there's a potential conjunction between two objects? And that has big implications because you go up there with only the amount of fuel that you can carry up there. There's no refueling stations in outer space, although that could change. But until that changes, there's no refueling stations in outer space. And so if you have to use some fuel to avoid collision with another space object, then that diminishes the life of your satellite and the commercial or scientific benefit that you're going to get from that satellite. I think that in the next decade, probably space traffic management is the biggest threat to our sustainable use of outer space. Now, we also need to manage the possibility of conflict in outer space. But the fact is, the Woomera Manual project is essentially demonstrating that there are laws that already apply to that. They're just not clear. We need more clarity about that. And there is some efforts going on right at this moment. So the United Nations First Committee, which focuses on disarmament, just on the 1st of November agreed to the establishment of something called an open-ended working group to think about norms that apply to outer space and will prevent an arms race in outer space. That's the ideal. So that's already happening. But there's not nearly enough happening in respect of space traffic management, and we need that desperately.
Yeah, awesome. Just another question. So the 2007 anti-satellite missile test that destroyed a Chinese satellite was a major space debris contributing event. What is being done to address similar events?
So, there is no prohibition on testing of anti-satellite weapons, even kinetic anti-satellite weapons. So the Chinese have not been the only ones. In fact, the US and Russia back in the 70s and 80s tested anti-satellite missiles and then discovered that actually it wasn't such a bright idea and created a lot of space debris and agreed on a moratorium between themselves not to continue with anti-satellite or ASAT testing. But in 2007, the Chinese tested an anti-satellite missile against one of their own weather satellites. The Americans actually, the following year, they blew up one of their own satellites. They said it wasn't a test. It was because this satellite had hydrazine in it, which is a very toxic substance, and they didn't want it to come back down to Earth. Whether that's the case or not, they effectively demonstrated to the world, hey, we can still do it too. And that's probably valuable strategically from their perspective. So it may or may not have been an ASAT test. The Russians had one of their satellites that collided with another satellite that may or may not have been an anti-satellite test. Seems unlikely, but some people have suggested that it could have been deliberate. In the last couple of years, the Indians have tested an anti-satellite missile as well and blew up one of their satellites. And so in all of these cases, they've created a lot of space debris. Now, the Americans and the Indians say, well, we did it at relatively low Earth orbit, or relatively low orbit, and the pieces of debris all deorbited within, between 6 months and a year. The vast majority of the debris had deorbited, whereas the debris from the Chinese test is still in orbit and is going to be in orbit for a very long time. Now, there is something, Article 9 of the Outer Space Treaty talks about if you have a reasonable expectation that your activity would cause harmful interference with the activity of another spacefaring nation or space active nation, then there's an obligation to engage in international consultations. And you would have expected a lot of states to pick up on that and say, well, you should have consulted before you did that. And in fact, states saying things like that out loud is actually really important in the formation and ongoing development of international law. So their failure to say something out loud diminishes the strength of a norm about harmful interference, for example. And so it's disappointing that in response to all of those incidents, the response of the international community was relatively muted. In fact, I think it was only Japan who said, Article 9 says that you should have consulted. Where were your consultations? The rest of the international community didn't make any specific legal reference. They just said, well, this is unfortunate. This is not great practice. So there isn't a strong legal norm against testing of anti-satellite missiles. And so a Canadian institute, the Outer Space Institute, has written a letter essentially to the United Nations General Assembly recommending that work be done to develop a legally binding mechanism, a legally binding instrument, a treaty, to prohibit the testing of anti-satellite weapons. So not prohibit anti-satellite weapons, because that might be unrealistic. You just wouldn't get states to sign up to that, but to prohibit the testing of those weapons. The Americans, on the other hand, have taken the approach of wanting to prohibit any activity that caused long-lived space debris. So they'd say, well, we don't have a problem with activities that cause short-lived space debris, because their own blowing up of a satellite in 2008, Operation Burnt Frost, I think it was called, created space debris for around 6 months. But we are concerned about long-lived space debris. So there are efforts to develop an international instrument about space debris, but nothing really exists at the moment.
Yeah, thank you. So we have one last question. Any advice or steps students can take if they are interested in space law?
In space law, well, there are many ways that you can contribute to space activities, and space law is just one of them. We've got 90 years on this earth, 33,000 days, or about 800,000 hours, and that's not that much really. So we can't do everything. As I said before, we have big challenges on this planet, and planet-sized challenges require planet-sized collaboration. We need people to do all sorts of things. But if you're a lawyer, actively seeking out a aeronautics engineer to give you a new perspective on existing challenges is important. If you're an aeronautics engineer, maybe seek out randomly a physiotherapist to give you a new perspective. So I wouldn't say, lots of people need to go out there and study space law. I think it's fascinating, and I encourage people to do that, but everything is valuable. All of it is valuable. I encourage that. But if people are interested in space law, then there are courses that are available in Australia. So University of Adelaide does a course in space law. Western Sydney University and ANU do courses in space law. UNSW Canberra Space, I convene a course called Space Cooperation, Conflict and Competition, of which space law is a part. If you want to do space law, you don't necessarily have to do a whole degree or become a lawyer necessarily. And if anybody's interested in doing space cooperation, conflict and competition at UNSW Canberra, then please look me up, and I very much welcome you as students. There's also the Space Law Council of Australia and New Zealand. It's another way to get involved in space law, and we'll be convening a conference probably somewhere between April and June next year. Haven't 100% narrowed down the date.
Thank you for providing such valuable answers to our students' questions. So how can the students contact you if they had any questions?
So, my UNSW email address is pretty straightforward. It's just duncan.blake@unsw.edu.au. So, if you're interested in finding out more or in the course that I just referred to, then let me know.
Awesome. So to wrap up, Duncan, do you have any last messages for the students who are listening?
As I said in the TEDx talk, space is for everyone. It's not just for this generation, it's for the next and future and every future generation. We all need to be involved. We all need to be concerned. We all need to have a say. So please do so.
Thank you so much. Okay,
no worries.
Thank you for joining us today and sharing your wisdom with the students of AIAA UNSW. And I myself have learned so much about the legal aspect of space, and it was a pleasure meeting you and talking to you today. Thank you.
Thank you. Good to speak with you.